Hi guys, how are you? Today I am going to discuss one important name reaction called Shapiro reaction, and this reaction has very high importance in organic synthesis. So we'll discuss in this video the general reaction, some examples, mechanism, and some question from previous year competitive exam. So let's say this is a keto which will be converted into an tosyl hydrogen, and then it will react with two equivalent strong base such that N-butyl lithium or LDA, lithium diisopropylamine, then it will be converted to an alkynyl lithium species, and that must be less substituted alkene, and then it is treated with an electrophile to form the less substituted alkene product. This is the general scheme of this reaction. So we'll discuss the mechanism. So you all know the reaction between the tosyl hydrogen and the ketone. Here one molecule of H2 will be removed and double bond will be formed, and from that, if it is treated with two equivalent N-butyl lithium, then this strong base will abstract two proton. This is quietly acidic, and here between these two alpha proton, this is more acidic. That is because the methyl group which will operate plaza effect, actually this will form a 2-degree carbon ion, this will form 1-degree carbon ion, so this is more acidic. So the two equivalent N-butyl lithium will abstract two proton, this proton and this proton, and a dianion will be formed. So this dianion will be formed. This butyl lithium will abstract this proton, as well as here one butyl lithium will abstract another proton. From this dianion, tosyl group will be removed, now one molecule of nitrogen will be removed, so the alkynyl lithium species will be formed. Now if it is treated with an electrophile, the substituted alkene, less substituted alkene will be formed. Why less substituted alkene will be formed? Because the butyl lithium will abstract the proton from less substituted carbon, from the more acidic carbon. Between these two hydrogen, this is more acidic than this, because this will form a 2-degree carbon ion while it will form 1-degree carbon ion. Now we'll take one example. Let's say if this is treated with tosyl hydrogen in presence of H plus, then the corresponding hydrogen will be formed, and if it is treated with two equivalent N-butyl lithium, so that Shapiro reaction will take place and the lithium, alkynyl lithium will be formed, and then it will react with D2O to form the deuterium substituted alkene. And now we'll discuss examples from different competitive exam. One question came, we have to convert this molecule into this molecule. COOH. Here is a double bond, this molecule. So what will use? This will be converted easily by using the Shapiro reaction. If we treat this is treated with 2 equivalent n-butyl lithium, 2 equivalent n-butyl lithium, then what will happen? Here this carbonyl group will be converted to first it will be converted to tosyl hydrogen, NH2 NHTS, so that it will be in NHTS, and then if it is treated with 2 equivalent n-butyl lithium, so here the benzene ring is there, so less substituted alkene will be formed. Here the only option is this hydrogen will be abstracted by butyl lithium, so this alkynyl lithium will be formed, and if it is treated with CO2 as electrophile, so it will react with CO2 and form the carboxylate anion, and then if it is acidified we will get this carboxylic acid. Another reaction that came in UGC-CSIR-NET, this ketone is treated with TSNH2 in ETOH, so it will then 2 equivalent n-butyl lithium in THF, then DMF, that is dimethyl formamide, HCOONMe2. This is dimethyl formamide. Now as you can see, if it is treated with this, then it will be converted to tosyl hydrogen, then 2 equivalent n-butyl lithium. So here both this site are same, so one of the alkynyl lithium species will be formed, so this will be formed, and then if it is treated with DMF is the synthetic equivalent of a formyl group. It is the synthetic equivalent of formyl group, this. So this lithium species will attack, it will attack here, and it will be converted to the formyl, CHO, this. Now we'll take another example. This tosyl hydrogen is treated with 2 equivalent n-butyl lithium, and then HCHO. So here the electrophile is HCHO, and here two possibilities there: proton abstraction from this side as well as this side, but as we know that Shapiro reaction will form the less substituted alkene, so preferentially this proton will be abstracted and double bond will be formed here. So the alkynyl lithium species that will be formed, here the lithium will be here in this carbon, so formyl group will be in this carbon, Now first this alkyl lithium species will be formed, and it is treated with HCHO, so it will be CH2OH. Now if it is treated with ethyl orthoacetate, MECOET3, in presence of acid catalyst, then one named reaction called Johnson-Claisen rearrangement will take place. If this is treated with ethyl ortho format, then this will be converted into this and after that, if it is heated, then a 3,3 sigma tropic rearrangement will take place. Here 1 2 3 1 2 3, so a 3,3 sigma tropic rearrangement will take place. This reaction is known as Johnson-Claisen rearrangement. Johnson-Claisen rearrangement. Double bond CH2 CH2 C double bond O OET. So this will be the product. Now we'll take another example that also came in UGC CSIR-NET exam. Here a bridged bicyclic system. In this position, tosyl hydrogen, it will react with N-butyl lithium 2 equivalent and then DMF, that is dimethyl formamide. So here also only one possibility is there, proton abstraction from this side is possible only. So the alkynyl lithium species that will be formed here is this, and when it will react with DMF, DMF is the synthetic equivalent of formyl group, so it will convert into a formyl group. So this will be the product. So guys, if you have any doubt regarding this video, please let me know in comment box, and to get such interesting videos, subscribe my channel. Thank you. Have a good day.